Okay, let's dive right into this fascinating explainer. Today, we're taking a seemingly simple web page and completely uncovering the massive digital ecosystem that is hiding right in plain sight. Think about your everyday routine for a second. We constantly click links, navigating through millions of URLs just to quickly grab a file, maybe skim an article, or double check a single fact. It's an incredibly seamless experience, right? And honestly, because it's so seamless, we rarely stop to actually look around. We almost never consider the immense, towering architectural machinery that frames the specific content we're after. It's kind of like walking into a massive skyscraper just to read a single sticky note left on a desk in the lobby, completely ignoring the structural engineering towering above you. Well, today we are going to look up. We're going to deconstruct one specific single-page view on GitHub to reveal exactly how a solitary piece of academic coursework is surrounded by literally some of the most advanced enterprise computing infrastructure on the planet. So, here is our game plan. We'll start with the cloud computing artifact itself, unpack the anatomy of a repository, step into the AI and automation era, look at security at scale, and finally, zoom out to the broader developer ecosystem. All right, Section 1, the Cloud Computing Artifact, Unearthing the File. Let's start our journey by looking at the exact item a student or developer arrived on this page to actually find. The breadcrumbs here precisely locate our artifact, a PDF detailing a core networking algorithm within a very specific educational repository. We're looking at a file named 0030.2 Bellman-Ford Algorithm.pdf. Notice how deeply buried it is. It sits neatly inside a folder called Network Fundamentals for Cloud, which itself is housed in the root bits-wilp-cloud computing project. This is the micro-level focus. It's the destination. It's literally the only reason a user would specifically navigate to this URL. Everything else we are about to explore, the menus, the sidebars, the footers, is just the vehicle used to get us to this one destination. Now, this incredibly specific number, 2.29, represents the file size in megabytes. It highlights just how remarkably small this single piece of coursework actually is. To put that into perspective, in the grand scheme of modern data, where we're streaming gigabytes of high-definition video without a second thought, a 2.29 megabyte PDF is basically a single grain of sand. Yet, as you'll see, the digital beach this grain of sand rests on is engineered to withstand a hurricane. And this brilliantly illustrates the temporal layers of the page. We move from the exact moment user Samrat P locked this file into history 3 years ago, right up to the real-time session tracking of the present day. You see, the repository captures a completely frozen moment in time, a commit uploaded 3 years ago. But the page rendering that file? It is incredibly alive. It's actively monitoring your current tab session in the background. It's constantly checking your permissions, tracking cookies, and it'll even warn you to reload if you signed in or out somewhere else. Plus, it's wrapped in a modern, present-day copyright footer. So this isn't just some dusty archive. It is static history actively living inside a highly dynamic, real-time application environment. Moving right along, Section 2, Anatomy of a Repository, the Social Code. So the crucial point to understand here is that this file doesn't exist in a vacuum. It lives inside a repository that acts as a collaborative workspace. Notice the number 42. In this ecosystem, that's the number of forks. But what does that actually mean? Well, a fork means 42 different people looked at this project and decided to create a complete, independent replica of it. They copied this exact workspace to build upon it, modify it, or study it completely on their own. When a student or developer looks at this Bellman-Ford Algorithm PDF, they aren't just downloading a file to their hard drive. The platform actively encourages them to duplicate the entire environment, turning a static file into their own personal, interactive sandbox. Furthermore, 33 users have starred this repository. This acts as a really powerful form of social currency. Think of it kind of like a like or a bookmark on traditional social media, but strictly for utility and knowledge. By starring it, these users are basically signaling to the rest of the community that, hey, this is a valuable educational resource. And that completely transforms a standard file host into a collaborative hive mind. The platform isn't just a place to park data, it's a social network built entirely around code, knowledge sharing, and peer-to-peer collaborative learning. Now, by looking at these specific metrics, 0 issues, 0 pull requests, and 0 security alerts, we can easily deduce the current state of this environment. It tells us this is a static reference library rather than an actively developed software project. Remember, this is academic coursework. It's finished, it's graded, and it's largely dormant. Nobody is currently reporting bugs with this networking curriculum, and nobody is trying to merge new code changes into it. It is incredibly peaceful. But right above this quiet, dormant library, a massive, globally scaled machine is absolutely humming. Which brings us to Section 3, the AI and automation era, tools in the periphery. It is honestly staggering to realize that while you're looking at a basic college networking algorithm, you are literally just one click away from next-generation software development tools. The sheer absurdity of this juxtaposition is wild. You arrived at this URL just to read a fundamental networking concept, maybe to cram for a test, yet the platform's navigation menu, hovering right at the top of your screen, is subtly offering you the absolute bleeding edge of software engineering. It's like going to the local library to check out a textbook, and the librarian casually hands you the keys to a spaceship. The platform actually wraps this simple file with an AI-powered developer platform designed to automatically write code and direct intelligent agents. Just look at the options available right there. GitHub Copilot to write better code with AI, and direct agents from issue to merge. Let's break down what that actually means. It means you can give an artificial intelligence a simple text prompt, and it will write, test, and integrate the code for you. The ecosystem hosting this static 3-year-old academic PDF is simultaneously training and deploying advanced artificial intelligence meant to write the software of the future, and it is all happening in the exact same interface. These navigation links represent a complete sequential pipeline for developer workflows. It takes an idea all the way to automated deployment. Let's walk through this deliberately. If someone wanted to, they could read that 2.29 MB PDF and immediately plan a new application based on it using issues. Then they could click Codespaces. For those unfamiliar, Codespaces spins up an instant virtual machine, essentially an entire, incredibly powerful computer running entirely in your browser window. You write the code there, have your peers review it, and then you use actions. Actions are essentially automated robots doing the heavy lifting, taking your finished code and instantly deploying it out to cloud servers across the globe. The entire lifecycle of software creation is just sitting right there, waiting in the header menu. Up next, Section 4, Security at Scale, Protecting the Ecosystem. Now we examine how a platform hosting millions of simple PDFs must simultaneously operate as an impenetrable fortress. While our user, SamRatP, simply uploaded a class file 3 years ago, the surrounding infrastructure is actively equipped to find vulnerabilities and stop secret leaks before they even start. Because this exact same platform is used by major corporations, it's running aggressive protocols like code security as you build and secret protection constantly in the background. It is a brilliant, almost mind-boggling example of how individual, everyday users directly benefit from the rigorous, uncompromising security demands of massive enterprise clients. When we glance at the navigation menus, we see exactly how this platform maps its solutions across global industries and highly complex use cases. It categorizes its offerings by industry: healthcare, financial services, manufacturing, and government. Take a moment to really think about that scale. The exact same foundational infrastructure that is currently supporting a computer science student's homework is also simultaneously securing the application modernization for global banks, protecting sensitive healthcare data, and running mission-critical government infrastructure. The true massive scale of this digital artifact's home really starts to come into focus. Finally, Section 5, the broader developer ecosystem, beyond the code. For our final stretch, let's zoom out to the absolute macro level, looking at the community and support structures underpinning everything. The platform actively funds open source developers and maintains global community programs right alongside standard repository hosting. Through features like GitHub sponsors to directly fund independent developers, and the archive program aimed at literally preserving code in an Arctic vault for future generations, we see that the platform is not just a digital utility, it acts as a digital society. But why do this? Well, because it creates a symbiotic loop. Fostering an ecosystem where maintainers are supported and security researchers are unified ensures the core platform thrives, which in turn powers the massive enterprise features we just talked about. The juxtaposition here is just incredible, and it's really the climax of what we've been unpacking. On the micro side, we have our quiet, unassuming 3-year-old Bellman-Ford Algorithm PDS. On the macro side, hovering right there in the enterprise menu are offerings for enterprise-grade 24/7 premium support and AI platforms. A solitary academic artifact is securely hosted within an ecosystem meticulously designed to run the largest financial and government institutions in the world. The stark contrast between the humble content we came to see and the massive industrial-grade container it sits in is pretty profound. Yet despite this massive enterprise scale, hidden right above the footer is this surprisingly human plea for user feedback. Amidst the artificial intelligence features, the automated deployment pipelines, and the global enterprise add-ons, there is a simple search query box and a feedback link assuring the user that, hey, humans are actually on the other side, reading their input. It is a wonderfully warm, grounding reminder that all this towering technology, all this architectural machinery, ultimately exists to serve people. And that brings us to the real takeaway here. The next time you click a link and land on a page just to download a file or read some text, take a second. Look at the menus. Look at the architecture. Consider the massive machinery that makes that single, instantaneous transaction possible. If a single academic PDF is wrapped in this much computing power and security today, what will the digital workspace look like tomorrow? It's a lot to think about, isn't it? Thank you for joining me for this explainer, and I really hope it changes how you look at the invisible architecture behind every single click.